Let's take a look at this unit. Now the first section is about quadratic functions and applications. So let's discuss that. Talks about a vertex form. In some books that's referred to as standard form. Okay, so quadratic function, vertex form, or like I say, it's also referred to as standard form. And that's when you got f of x is equal to a times x minus h squared plus k. Now if it's in vertex form, then we can tell different items based upon what the values of a, h, and k are, which are numbers. Now if a is greater than 0, it's positive, and my graph opens up. If a is less than 0, my graph opens down. Your vertex, which is also your highest point or your lowest point, is h, comma k. Your axis symmetry, which I'll abbreviate as AOS, is x equals h. And your min, if now you have a min, and this is based upon a, if a is greater than 0, it opens up. Or max, you don't have both. Your max is when a is less than 0. Your max is going to equal to k. So let's look at a problem. Let's say we got f of x is equal to negative 2 x plus 3 squared minus 1. And we'll find the vertex, axis symmetry, min or max, and we're going to graph it. First off, let's identify our letters. Whatever number's right here is your a, and if there is no number here, it's by default 1. So a is negative 2. Whatever's right here is going to be your h, and it'll always be opposite sign. So h is going to equal to negative 3. And then whatever's here is your k, so k is going to equal negative 1. Now if you're wondering, well, why does that sign flip on this? It's a positive here, but we wrote down a negative. Whenever you have a minus or a negative in your formula, that's when you flip your signs. Okay, now first off, I know a being negative, it's going to open down. Besides telling me the general shape of the graph, it also tells me I'm going to have a max, because it has a highest point. Remember, if a is less than 0, then you have a max. Now our vertex. Our vertex is going to be hk, and h was negative 3, and k is negative 1. Now our axis symmetry. That's going to be x equals h, and h was negative 3. So that's our axis symmetry. And we said we're going to have a max, and it's going to equal to k always. So k was negative 1, so our max is equal to negative 1. Now to graph this, got negative 3, negative 1. Now, you want to find one point. If you're doing this by hand, typically you either go 1 unit or 2 units away from the vertex. My vertex is at negative 3 on my x-axis, so I might choose negative 2 or negative 1. Typically, going 2 units away is best. So go to x equals negative 1. Now I'm going to plug that back into my function, remembering f of x is y. So we got y is equal to negative 2 times negative 1 plus 3 squared minus 1. Negative 1 plus 3 is 2, and 2 squared is 4. minus 1. Negative 2 times 4 is negative 8. Negative 1 is negative 9. See, this is one case where 1 unit away might give me a better picture. Because negative 9 is quite a ways down, but I might still be able to do it. Let's see. 3, 4, 5, 6, 7, 8, 9. So negative 1, negative 9 would be right down here. Okay, so that's not too bad. If you go too far away, what you're going to find is that it'll be so far down you can't really sketch it. And now that I have that, looks like this, and then this by symmetry goes down like this. The axis symmetry, it's symmetric, that line. So if we look at x equals negative 3, so I can draw a straight line. If we look at x equals negative 3, it's symmetric this line. So after you get to one side, you flip it over and you get the other side. Now I'm graphing that just to demonstrate, so you can visually see the vertex and what the axis symmetry is used for, and whether it opens up or down. But for purposes of this class, we'll plug it in the calculator. If you have a TA3, TA4, that is. Otherwise, you do like what I just said. Typically, 2 units away is fine. 1 unit is usually too close, but I think 1 unit might have actually worked pretty good in this case. Okay. So if I go to y equals, clear. And we got negative 2, beginning parentheses, x plus 3, closing parentheses, x squared, minus 1, and then graph. You can see a little bit better picture than what I drew. Use your calculator if you got a TA3 or TA4. Now that's vertex form. We also have something called general form. And this is when you got the form f of x is equal to ax squared plus bx plus c. A, b, and c are numbers of some sort. Okay, now up here we said if a is greater than 0, graph opens up. If a is less than 0, graph opens down. Still applies. Now our vertex is given by negative b over 2a, then f of negative b over 2a. That's actually called the vertex formula. Now our axis symmetry, I'll just abbreviate AOS, is x equals negative b over 2a. And our min is when we have a greater than 0. Our max is when a is less than 0, is equal to f of negative b over 2a. Now specifically, this is called the vertex formula. So let me show a little bit easier way to do the steps and with this formula. Vertex formula. Step 1 is to identify a and b. Step 2, plug these values into negative b over 2a and simplify. Step 3, plug the value from step 2 into the original function and simplify. Okay, now let me make up a problem. Okay, so got f of x is equal to x squared minus 4x plus 1. Okay, so first off, let's identify a, b, and c. A is whatever number is in front of your x squared, and if there's no number there, it's by default 1. B is whatever number is in front of your x, which is a negative 4. And c is whatever number is at the end, which is a 1. Now a is positive, which means right away I know it opens up, and I know it's going to be a min, because it opens up. Okay, so our vertex formula. Step 1. Identify a and b. We already said a is 1, we said b is negative 4. Step 2. Plug these values into negative b over 2a and simplify. So I'm going to have negative b, which is negative 4, over 2 times a, so 2 times 1. That gives us 4 over 2, or 2. Now this is the x part of the vertex. So that, what we just found there, is the x part of the vertex. Step 3, plug the value from step 2 into the original function, simplify. So we're going to take this 2, plug it back in our original function, remembering f of x is equal to y. So we got y is equal to 2 squared minus 4 times 2 plus 1. 2 squared is 4 minus 4 times 2 is 8 plus 1. 4 minus 8 is negative 4 plus 1, which gives us y is equal to negative 3. And this is the y part of the vertex. So that's y part of the vertex. So our vertex is going to be, from step 2 here, it's 2. And from step 3, it's negative 3. So our vertex will be 2, negative 3. Now axis symmetry. Even though it looks kind of bizarre in the formula, you'll notice that the axis symmetry, negative b over 2a, happens to match the x part of the vertex. And it does. Here, we're going to have x is equal to 2. We've already indicated we have a min. And notice what the min looks like. F of negative b over 2a, that matches the y part of the vertex, right there. So our min is going to be equal to negative 3. If you have the vertex, you pretty well have the other two items. And then for the graph, you just plug it in your calculator. Let me just show one more of those. So if I go to y equals, and put the keys back, I guess. Clear. X squared, so x key and then x squared minus 4x plus 1, and then graph. And that would be our graph. Let's see, right? This is vertex form. Probably the easiest way to write a parabola in general form is to go ahead and find the vertex and then just plug it into your vertex form. For example, this one we just did, we came up with the vertex of this. Remembering that this is h and this is k, we could very easily write this in our, let me see, x minus h squared plus k. We write that in our vertex form. Now a we said was 1. X minus h was just 2 squared. And then plus k, so plus a negative 3. So this would equal to x minus 2 squared minus 3. This would be our vertex form. So like I say, the easiest way, if it asks you to write a quadratic function in general form, into vertex form is just find a vertex using the vertex formula and then just plug it in. Now create quadratic models using regression. Let me just show that real briefly, and then we'll go on to the next topic. On your calculator, under Stat, do enter on edit. If you got a set of points here, and let me put a value in here, another one here, and I'll say this is 3,000, and this is 2,000. Now on your calculator, I'm going to exit out, so I'll do second mode. Now, if you're given x values and y values, you just go into Stat, you go into Edit, and you input your x values. I'm doing enter on edit. You just enter your x values here and your y values here. To create the model, what you can do is your diagnostics should be on, which they should be if you turned on earlier in the course. We go into a second 0 for the catalog. Push your x to the -1 button. That's actually your inverse button. It'll take you down to the D's. And you want to choose diagnostics on. Right there. And you press enter a couple times. It says done. Now if you do Stat, right arrow to Calc, and you want to choose number 5, Quadratic Regression, and then press enter. Now these A, B, and C you see here, you just plug into your formula, the ax squared plus bx plus c. So this is the way you can create a model. Okay, let me clear this off. And let's go on to section 3.2. Introduction of polynomial functions. And first thing it says is determine the end behavior. So let's take a look at that. Now we got a variable, which is a single letter. We got a term, which is a number times a variable, and I'll put an S on there to indicate you can have more than one, or a variable times a variable. And again, I'll put an S on there to indicate you can have multiple. Now, that's what a term is. We have a binomial, actually monomial, which is one term. We have a binomial, which is two terms. We have a trinomial, which is three terms. And then what we're studying here, which is a polynomial, which is one or more terms. We have something called standard form. This is when your terms in a polynomial are arranged from largest power down to the smallest power. We have the degree, which is your largest power of x. Although degree is a little bit more than that, that's going to be the best definition we'll use in college algebra. We have the coefficient, which is the number in front of the term. And when I'm talking about that, I'm talking in terms of multiplication, not addition or subtraction. We got the leading term, which is the first term when the polynomial is in standard form. We got the leading coefficient, which is the coefficient of the leading term. And I'm going to refer to this as coefficient. for purposes of what we're going to look at here. There's a lot of coefficients, but when I say coefficient all uppercase like that, I'm referring to coefficient of the leading term. We got the leading coefficient test. And this is a table. Your coefficient can be positive. Your coefficient, it can be negative. Those are your two choices. Your degree is even, or your degree is odd. Now, those are our choices. If your degree is even, the coefficient is positive, tells us it's up to the left, up to the right. If your degree is even and your coefficient is negative, it's down to the left, down to the right. If your degree is odd, your coefficient is positive, it's down to the left, up to the right. If your degree is odd and your coefficient is negative, it's up to the left, down to the right. Now let me show an example using that. If I had f of x equal negative 3x to the fourth minus 7x plus 2. And what this test tells us is what's it doing as it goes clear to the left, what's it doing as it goes clear to the right. All of it's based upon the leading term. So we're going to look at this negative 3x to the fourth. The coefficient is negative 3. So our coefficient is negative. So coefficient is negative, we're looking at this column here. Our degree happens to be the largest power of x, or it's also the degree on our first term, our leading term. Notice your degree is even. So coefficient's negative, degree is even. We look at the intersection of those, and that tells us down to the left, down to the right. So our answer, in terms of what's happening, is down to the left. You can read my writing, and it's down to the right. I don't know much else about this graph, but I do know as it goes clear to the left, it's going down. As it goes clear to the right, it's going down. Doesn't tell us anything about what's happening in the middle here. You can be doing a number of things here in the middle. All we know is it's going down to the left, down to the right. Now you might say, well, what use is that? Well, if we were graphing these by hand, you would find that's invaluable in helping you figure out what the graph should look like. Okay, let's take a look at another problem. And we're going to have f of x is equal to x to the third. Thought I could just do that in my head, but obviously I need to multiply it out. X to the third minus 3x minus 2. Now if I were to factor this, you probably couldn't factor because we haven't really talked about that yet, but it would factor as x minus 2 times x plus 1 squared. So these two are equivalent, assuming I multiplied this correctly here. Now, this next topic, says identify zeros and multiplicities as zeros. Well, if you set this equal to 0 and solve it, we got x minus 2 times x plus 1 squared equal to 0. Since it's already factored, I'm going to set each factor equal to 0. I'll set x minus 2 equal to 0, and I'll set x plus 1 equal to 0. And that gives us x equals 2 and x is equal to negative 1. These would be our zeros. Now, multiplicity. A multiplicity is whatever powers is on it. If I go backwards and x equals negative 1, it had a second power here, so multiplicity is 2. Now, the x equals 2, if I go backwards, didn't have a power, but if I would put 1 there, it would be the first power. So its multiplicity would be 1. And then a lot of books will ask you whether it touches or crosses the x-axis. And if it's even, then it touches. If it's odd, it crosses. Now, this is what it's referring to in terms of multiplicity and the zeros. I don't see where it's asking us to identify touching and crossing. But this last one, if we want to sketch a polynomial function, if you used your leading coefficient test. Now, this one would have a positive coefficient and a odd power. This would tell us it's down to left, up to the right. We know that at negative 1, it's going to touch. We know at 2, it's going to cross. And since I know it's down to the left, up to the right, then I know my graph's going to look like this. It'll come up, touch at a point, turn around, come back down. Now at some point, it'll turn around because it has to come back up here to cross. And that's more or less what our graph will look like. Now I say more or less because at this point you'd have to plot some more points to get an exact picture of it, because we don't know how far down this goes. Maybe it turned around sooner. Maybe it goes down further. I don't know. We'd have to maybe plug in x equals 0 and x equals 1 to figure that out. But this gives you a very rough sketch, so you can then modify it. Now, if I were to graph that on the calculator, if I do go to y equals clear x to the third minus 3x minus 2, and then graph. You can see I generally had the look, but it actually went down a little bit more that way. But we had the general shape of the graph. So again, that included in with plotting maybe 2 or 3 points, your t-chart can help you come up with a graph very easily. Okay. Let me clear that off. And we're going to look at division of polynomials and remainder and factor theorems. Grab a drink here. Long division. If I have x plus 2, and I divide that into x squared minus 7x plus 1, we look at first term of each side, what goes up on top. So you look at the x and the x squared. And you ask yourself, what times x gives you x squared? And that'd be x. Now, whatever we put up on top, we're going to multiply by what's out in front. So we're going to take x times x plus 2. X times x is x squared. X times 2 is 2x. So we're going to have x squared plus 2x. Now we're going to subtract that, which means flip signs. So this positive x squared becomes a negative. This positive 2x becomes a negative. X squared minus x squared drops away. Negative 7x, negative 2x is negative 9x. And then I'll bring down the plus 1. and then we repeat the process. We look at the first term of each, decide what goes up on top. You ask yourself what times x gives you negative 9x, and that's negative 9. Now whatever you put up on top, you multiply by what's out in front. So we're going to take negative 9 times x plus 2. Negative 9 times x is negative 9x. Negative 9 times 2 is negative 18. We're going to subtract that line, which means flip signs. So negative 9x becomes a positive. The negative 18 becomes positive. Negative 9x plus 9x cancels. 1 plus 18 gives us 19. Now, our degree of x plus 2 is 1. Degree is the largest power of x. Our degree of 19 is 0. When the degree of what you have down here is less than what you're dividing by, then you stop, and this is your remainder. Then you put your remainder over what you're dividing by. And that would be your answer. Now let me look at one more problem, long division-wise. Let's say I had x squared plus 3x minus 1. And I have x minus x to the third plus 4. Now, two things have to be true for you to do long division. What's out in front has to be in standard form, and you can't have any missing powers. Well, this is already in standard form. X squared plus 3x minus 1. Largest power down to smallest, and we're not missing any powers. We got x squared, x, no x. And what's inside has to be in standard form. So the x to the third has to go first. So when I rearrange it, the number that's in front of it has to stay in front of it. Now there is no x squared, so here we put 0 placeholders. So plus 0x squared plus x plus 4. So again, it's in standard form. Terms range from largest power down to smallest, and we're not missing any powers. We then go through the same process. You ask yourself what times x squared gives you negative x to the third, and that's negative x. Now whatever you put up on top, you multiply by what's on front. Negative x times x squared is negative x to the third. Negative x times 3x is negative 3x squared. Negative x times negative 1 gives us a positive x. Now we want to subtract that line, which means flip signs. So this negative x to the third becomes positive, this negative 3x squared becomes positive, this x becomes negative. Negative x to the third plus x to the third drops away. 0x squared plus 3x squared is 3x squared. X minus x gives us 0x, and then plus 4. And then we repeat the process. You look at the first term of each side, what goes up on top. You ask yourself what times x squared gives you 3x squared. And that'd be 3. And whatever you put up on top, you multiply by what's on front. 3 times x squared is 3x squared. 3 times 3x is 9x. 3 times negative 1 is negative 3. We're going to subtract that line, which means flip signs. So this becomes negative, negative, positive. 3x squared minus 3x squared drops away. 0x minus 9x is negative 9x. 4 plus 3 is 7. Now the degree of what we have here is 1, and degree of what we're dividing by is 2. So whenever the degree is less here, then that's a remainder. So we're going to have negative 9x plus 7. And we'll put that over x squared plus 3x minus 1. And that's our answer. Let me clear that off, and we'll look at synthetic division. A lot of people like synthetic division better than they do long division, or that's also called polynomial division. Let's say we got x squared minus 7x plus 2, and we're dividing that by x plus 3. Now our first step in synthetic division is you always take what you're dividing by, which is x plus 3, set it equal to 0, and then solve it. So that gives us x is equal to negative 3. Now our second step. We take the value we just found, we put in a box in the upper left-hand corner. Now we look for our largest power of x, and our largest power of x is x squared. So real small across top, I'm going to write x squared, x, no x. You start with your largest power and you have 1 for each one going down. The no x is our constant term. And then I write down a number that's in front of each one. The number in front of the x squared is a 1. Number in front of the x is a negative 7. And the no x is a 2. Now we're going to add. 1 plus nothing is 1. Then you multiply. I should say the adding and multiplying, you alternate those back and forth. So we're going to multiply. You always multiply by the number in the box, by the number you put down here. Negative 3 times 1 is negative 3. Then we're going to add. Negative 7, negative 3 is negative 10. Then you multiply. You always multiply by the number in the box, by the number you put down here. Negative 3 times negative 10 is 30. And then we're going to add. 2 plus 30 is 32. Now this was x squared. Straight down below it will be 1 degree lower. So this will be x. And after you have your first one, then it has 1 for each one going down. That's x. This is a no x, our constant term. And this is our remainder. So our answer will be x minus 10 plus our remainder, which is 32, divided by what we're dividing by. 32 over what we're dividing by. divided by what we're divided by. Even though it's correct, didn't sound right. Now let's say I had 2x to the third minus 7x plus 1, and I'm dividing that by x minus 1. Now same steps. So our first step, we take what we're dividing by, which is x minus 1, set it equal to 0, and solve it. So we get x equals 1. Now step 2, we take the number we just found, put it in a box in the upper left-hand corner. Now we need to identify our largest power of x. Our largest power of x is x to the third. So real small, I have x to the third. I'm going to have an x squared, x, and no x. So again, start with the largest power, you have 1 for each one going down. The number that's in front of x to the third is 2. There is no x squared, so that's where you put a 0. The number in front of the x is negative 7, and our no x, our constant term, is 1. And now we're going to do adding, multiplying over and over till we're done. First thing we'll do is add. 2 plus nothing is 2. Then you multiply. You always multiply by number in a box, by number you put down here. 1 times 2 is 2. Then I want to add. 0 plus 2 is 2. And then I want to multiply. You always multiply by number in a box, by number you put down here. 1 times 2 is 2. Add. Negative 7 plus 2 is negative 5. Multiply. You always multiply by number in the box, by number you put down there. 1 times negative 5 is negative 5. And then add. 1 and negative 5 gives you negative 4. Now this was x to the third. Straight down below will be 1 degree lower. So this will be x squared. Now after we have our first one, we have 1 for each one going down. So x squared, x, no x, and a remainder. So our answer will be 2x squared plus 2x minus 5 plus, you take your remainder, which is negative 4, over what you're dividing by, which is x minus 1. And that's our answer. Now that was dividing using long division and synthetic division. Let's take a look at the remainder theorem. I'm not going to look at the factor theorem. I won't look at that until the next section. It'll make more sense once we look at it there, because we'll actually use it in a practical sense. Okay. The remainder theorem. Let's say we have f of x is equal to x to the third minus 2x squared plus x minus 7. And we want to find f of 2. Well, our old way. This has nothing to do with remainder theorem, I'm just helping you see the connection. Our old way to find a value of a function, evaluate the function, we take the number inside of parentheses here and plug it in for the x here. So we're going to have 2 to the third minus 2 times 2 squared plus 2 minus 7. 2 to the third is 8. 2 squared is 4 times 2 is 8, so we got 8 minus 8. And then 2 minus 7 is going to give us negative 5. And 8 minus 8 drops away, and we get negative 5. Not too hard. The new way. This is a remainder theorem. It says if you're evaluating a polynomial function, what you can do is you can plug the value you're evaluating for into synthetic division. So we'll take the 2, that's the f of 2 right here, put 2 in a box. Now our largest power is x to the third. So we're going to have an x to the third, we'll have an x squared, we'll have an x, and we'll have a no x. So we've got 1, negative 2, 1, negative 7. If it goes through synthetic division, I'll learn to speak someday, you're going to get this. Now look at what your remainder is. Your remainder happens to match what our answer is. That's no coincidence. That's what the remainder theorem says. It's just another way of evaluating a polynomial function. You can just plug in synthetic division, your remainder is your answer. Okay, let me clear that off. And this next topic, there's apply the rational zero theorem, fundamental theorem of algebra. We'll do one of these by hand, and then I'll focus on using the calculator for it. And let me choose an appropriate one by hand. I'm trying to think of one that won't take me forever to do. They're not necessarily that easy by hand. Okay, let's take a look at this one. F of x is equal to x to the fourth minus 6x to the third plus 30x minus 25. And let me grab a drink here. Now the rational zero theorem. Now our zeros are our answers when we set this equal to 0. So if I set the x to the fourth minus 6x to the third plus 30x minus 25 equal to 0, the largest power, which is the fourth power, tells us how many answers we're going to have. We're going to have 4 answers. And zeros are our answers. It's what values of x cause us to be true. It also happens to match, in some cases, where it crosses or touches the x-axis. Those are our real zeros. Well, to find out our possible rational zeros, and that's what this is referring to, the rational zero theorem, we have to identify our p, which is our number here at the end, and we have to identify our q, which is a number at the beginning. This is assuming it's in standard form. So our p is 25, and our q is the invisible 1. Now I want to list all the products that give us 25. Well, we got 1 times 25. We also got 5 times 5. Since the number is repeated, I won't write it down twice. That's not quite true. 1 times 25 gives you 25, but also negative 1 times negative 25 gives you 25. So we have to account for that by putting plus or minuses before each one of these. Now our q. Q is 1. The only thing that gives you 1 is 1 times 1. But again, I'll put a plus or minus 1 here. Now all of our possible answers, this is the rational zero theorem, is all the values of p over q. So I'll put 1 over 1. And I'll put a plus or minus in front of it to count any possibilities of signs. I'll put 5 over 1. And I'll put 25 over 1. And 1 over 1's 1, 5 over 1's 5, and 25 over 1 is 25. So these are all our possible rational zeros. Now that's the first part, rational zero theorem. Now the fundamental theorem of algebra. We're going to use this, and we're going to progress further. That's all that would be needed for that first part. But we're going to take these, and we're going to plug them into synthetic division and see which ones work. So let's start with negative 1. Now our largest power is x to the fourth. Remember, we need an x to the fourth, an x to the third, an x squared, an x, and a no x. The number that's in front of our x to the fourth is 1. Before the x to the third is negative 6. Before the x squared, there is no x squared, so that's 0. Number in front of our x is a 30. Number at the end is negative 25. Okay, so I'll go through this fairly fast. You need to feel comfortable with synthetic division before you do this process. Of course, having to go through this fairly fast, I might mess it up. Now what we're looking for is we're looking for our remainder to be 0. So negative 1 is not an answer. If we come up with a remainder of 0, that means we found an answer. So let's plug in positive 1. And see what we get. Let me double check that. I didn't think that was going to be our first answer. But I can't look at these and see them. Also can't make them up, that's why I'm pulling it off the PowerPoint. Okay. We found a 0 as a remainder. That means we found an answer. That means this number in this box here is our first answer. So x equals 1 is our first answer. That's the factor theorem. Up here, I skipped over the factor theorem. I said we'd talk about it later. If you go through synthetic division and you come up with the remainder of 0, that means you found an answer. You found a 0, which is also a factor. We could rewrite it that way. Now this was x to the fourth, and now we're down to x to the third. Now we're going to see if we can find another answer. Now, just because we found 1 as our first answer doesn't mean 1 is our second answer. So what we're going to do is we're going to plug 1 in this line we just found. So it's a continuation. And it appears like we didn't get a 0 as a remainder. Now I want to still focus on the x to the third. So I'm going to focus on 1, negative 5, 25. This is a new line we found. We never go back to the old line once we found a 0. Now we're going to plug in our second value. Let's plug in negative 5. So add, multiply, add, multiply, add. That's not going to work. Okay, let's plug in 5. Okay, add, multiply, add, multiply, add, multiply, add. We get another 0's remainder. That means we found our second answer. So our second answer is a number in the box here, x equals 5. Now we were at x to the third here. We're now down to x squared, and this is x, and this is no x. Your goal is to get it down to the x squared level. So we're now down at x squared minus 5 equal to 0. And we want to solve this. I can use square root property. So I take negative 5 over to the right side, becomes a positive 5. Square root property says we drop our squared, and you put a plus or minus square root on the other side. And those are our other two answers. So The fundamental theorem of algebra says your largest power tells you how many answers you're going to have. So 4 tells us we're going to have 4 answers. We found one answer, x equals 1 there. We found x equals 5, and then we found plus or minus square root of 5. So that counts for all 4 of our answers. Now we're going to use a calculator to do this. That's how you do it if you're doing it by hand. Kind of a tedious process. Now I'm going to repeat this process using TA3, TA4. So finding zeros on a TA3-84. Step 1. We're going to put a polynomial on y1, 0 on y2. Step 2. We're going to do a second trace. We're going to choose intersect. We'll enter on first curve. We'll enter on second curve. We'll input an x value close to our answer and press enter. Step 3. If we have decimals, then we're going to exit out, do a second mode, and then we'll do math, enter, enter. Now this is assuming it actually would change to a fraction. And then step 4, if more answers, go back to step 2. And then step 5, plug the answers into synthetic division and use this to find the rest of the answers. This is assuming you didn't find all of your answers in the first place. Okay, so let's see what in the world I mean by that. Now we're finding zeros. When you're finding zeros, what you're basically doing is you're setting your polynomial equal to 0 and you're solving it. So we got that right there. Okay, if I put that into my calculator, go to y equals clear, x caret 4 minus 6x to the third plus 30x minus 25. And you have to have a 0 on y2. So you down arrow to y2 and you put a 0 there. This process does not work unless you have a 0 on y2. Now I'm going to put my large screen here so you can clearly see what's going on. And I'll hide my picture there so you can see. But we're at step 2, second trace. So do second trace. We want to choose intersect. So you can down arrow to number 5 and press enter on it. Or you can simply press a 5. You press the numbers in front of it and that very quickly chooses it. Now, our answers are where it crosses the x-axis. Looks like it crosses here somewhere near -2. Notice it's asking us. It says first curve question mark. We just do an enter on that. Then it's asking us for second curve question mark. You simply do an enter on that. And then I put in -2, an x value close to our answer, and press enter. Comes back and tells us -2.236068. Now, I have a decimal, so that's step 3. Second mode, math, enter, enter. So second mode, math, enter, enter. It doesn't change to a fraction, which means we can't use it. Well, let's find our second answer. So I'm going back. If more answers, go back to step 2. So we're back at step 2. Second trace. Choose 5 for intersect. Our next answer, going from left to right, looks like 1. So we'll do enter on first curve, enter on second curve, and then I'll put 1 in for the guess and press enter. Now notice it comes back and tells us our intersection is x equals 1. That's telling us our first answer. So they're telling us that x equals 1. Now our next one looks like 2. If I do second trace, choose intersect, enter our first curve, enter our second curve, and I put 2 in for the guess. It tells us 2.236068. Well, we know how to handle decimals. We exit out, second mode, and then we'll do math, enter. And it doesn't change. A lot of times they won't, but sometimes it will. Well, we can't use that because it's not a fraction. Well, let's continue the process. We'll do second trace, choose intersect. Our next one looks like 2, 3, 4, 5. So we'll do enter our first curve, enter our second curve, and for the guess I'll put in 5. You don't have to input the answer to get the answer. That'd be kind of a stupid feature if you did. If you put in 4, you put in 6, it'll find the one closest to your guess. I tend to get in the habit of always inputting what I think the answer is. Okay, it'd been nice if we found all 4 answers via the calculator. Remember, your largest power tells you how many answers you're going to have. But we found 2. We can work with that. What we're going to do is we're going to start with our first one, and we'll plug it into synthetic division. So we got 1, -6, 0, 30, -25. And this was x to the 4th. So I add, multiply, add, multiply, add, multiply, add, multiply, add. Notice we get a 0 as remainder. That means we found our first answer. So this number in this box, x equals 1, is our first answer. No big surprise. Calculator told us it was going to be one of our answers. So you better get a 0 for the remainder. Now this was x to the 4th. That takes us down to x to the 3rd. And we want to plug in the second answer the calculator gave us. So we'll plug in 5. And then we add, multiply, add, multiply, add, multiply, add. We get another 0 as remainder. That means we found our second answer. No big surprise, calculator told us is going to be an answer. Each answer you find takes it down one more power. This was x to the 3rd, so we're now down to x squared. And this will be x, and this is our no x. So we have x squared minus 5 equal to 0. I'm going to take -5 over, becomes a positive 5. And using the square root property, we drop our squared and we put a plus or minus square root around the other side. And that gives us our last 2 answers. The plus or minus counts for 2 answers there. Now that'd be the fundamental theorem of algebra using the calculator. It's actually finding zeros using the topics of fundamental theorem of algebra. Now let's go on to rational functions. And some of these topics I'll skip over in the interest of time. Let me grab a drink here. I have lots more examples in YouTube videos so you can look at. This is just to kind of give you a brief introduction to each of these topics. Okay, rational functions. Let's say I have f of x is equal to 2x over x squared minus 5x plus 6. And they ask us to find something called a vertical asymptote. Now for our vertical asymptote. An asymptote is an invisible line in your graph will skim at some point. We'll talk more about that. Now finding vertical asymptotes. Step 1, factor the top, factor the bottom. Step 2, cancel if possible. Step 3, set the denominator equal to 0 and solve. Okay, so in this problem, 2x I can't factor, but the bottom can factor using the PSD. It factors as x minus 2 times x minus 3. Now I can't cancel. That was step 1. I can't cancel, so we go to step 3. Step 3 says set the denominator equal to 0 and solve. So we got x minus 2 times x minus 3 equal to 0. Zero factor property, you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0 and x minus 3 equal to 0. And that gives us x equals 2 and x is equal to 3. And these are vertical asymptotes. I don't know much about this graph, but if I were to graph it, then the graph is skimming the line x equals 2 and is skimming the line y is equal to 3. These are invisible lines your graph will skim at some point. Now let's just for fun look at this graph. Now the key to graphing a rational function is put parentheses around the top, parentheses around the bottom. Okay. Let's go to y equals clear, beginning parentheses, 2x, closing parentheses, divided by, beginning parentheses, x squared minus 5x plus 6, close parentheses, then graph. Now, if you visualize the line x equals 2, you can see it's skimming this as it goes up. So it's going to skim it forever, never touching it, never crossing it at that place. Now that doesn't mean for some asymptotes may not actually cross it, especially if you're horizontal asymptotes. Vertical asymptotes, it'll never cross them. And if I go to x equals 3, if I draw a vertical line there, it'll be skimming that. Now just for fun, let me go to my draw menu, and I choose vertical, and I'll put 2 in. Let's try that again. Okay, go to my draw menu, vertical, put 2 in. See, there's my vertical line, x equals 2. It'll be skimming it at that point. Now, if I did the same thing for 3, you may not be so obvious to see on that one. If I graph that, well, I thought I hit enter. Okay, enter. There it goes. You're saying, well, that's not skimming it. It will be if you go further up. If I were to zoom out, you'd see this skims it at some point. Getting really close to it, but never touching it, never crossing it. That's the definition of an asymptote. Now for a horizontal asymptote. Remember, the degree is your largest power of x. And I've been referring to the top, the numerator, and bottom, the denominator. So finding the horizontal asymptote. Well, we have 3 cases. Case 1, the degree of the top is larger. That means there is no horizontal asymptote. Case 2, the degree of the bottom is larger. That means a horizontal asymptote is y is equal to 0. In case 3, the degrees are the same. And I'm going to do this with an example, and then I'll make it a little bit larger after I do that so you can actually see it. Okay. So I got f of x is equal to, no, that's pretty large right there, 3x squared minus 7x plus 2 over 8 minus 5x squared. Now notice the degree of the top is 2, the degree of the bottom is 2. Degrees are the same. So what we do is we create a fraction, y equals the fraction, and we take the numbers off the front of the x to the largest power. Take 3 off the x squared on top, and take the negative 5 off the x squared on the bottom. So our horizontal asymptote will be y is equal to negative 3/5. This problem we just did here. Degree of the bottom is larger. Degree of the top is 1, degree of the bottom is 2. So degree of the bottom is larger. That tells us the horizontal asymptote is y is equal to 0. Here we had our vertical asymptotes. And if we looked at our graph, you see how it's skimming? I don't know how to get rid of those vertical lines, but oh well, I'll leave them on there. I know if I clear the entire thing, it'll disappear. But, let me do that. Okay, now they're gone. So I got, was it 2x on top? Divided by x squared minus 5x plus 6, and then graph. Now, we've already talked about the vertical asymptotes, how it's skimming those lines, but look at the horizontal. This graph is coming down, and it's crossing the horizontal asymptote and skimming it from the bottom. Now, over on this side, it's coming down. It's not going down below, but it's skimming it from the top. So, you can see it's skimming the horizontal asymptote, y is equal to 0. Now, let's talk about the slant asymptote. Now, in order to have a slant asymptote, the degree of the top must be exactly 1 larger than the bottom. And what you do is use long division and drop the remainder. Now, some books refer to the slant asymptote as the oblique asymptote. Now, I don't even know what this book refers to it as. Slant asymptote. But if you've heard oblique, that's the same thing. Now you make up a problem. Let's say I got f of x is equal to x squared minus 3x plus 1 over x minus 2. Now, it does have a slant asymptote because the degree of the top is 2, degree of the bottom is 1. So the degree of the top is exactly 1 larger than the bottom. So to find a slant asymptote, we said we use long division. In some cases, you can use synthetic division. You can always use synthetic division if you're dividing by x plus a number or x minus a number. But I'll do long division because that works on 100% of the slant asymptote problems. Now look at the first degree, or look at the first term of each. Look at the x and the x squared. And you ask yourself what times x gives you x squared, and that's x. Now whatever we put up on top, you multiply by what's out in front. X times x is x squared. X times negative 2 is negative 2x. We'll subtract that line, which means flip signs. So it becomes negative, this becomes positive. X squared minus x squared drops away. Negative 3x plus 2x is negative 1x or negative x. Now bring down the plus 1. Now again, we look at the first term of each side, what goes up on top. X times negative 1 gives us negative x. Whatever we put up on top, you multiply by what's on in front. Negative 1 times x is negative 1x or negative x. Negative 1 times negative 2 is a positive 2. We'll subtract that, which means this becomes plus, this becomes a negative. Negative x plus x cancels. 1 minus 2 is negative 1. And this is our remainder. And we said drop the remainder. So our slant asymptote is right here, and it's y equals whatever you have on top. So that's our answer. Now if you're wondering, well, what's that used for? Well, if I graph the slant asymptote, y is equal to x minus 1, it's an invisible line your graph will skim at some point, so I don't want to actually make it a solid line. And our vertical asymptote is 2, so if I were to put that in also, geez, let's try that again. Not very good with straight lines, I guess. Knowing it skims those, I could find, for example, my intercepts. Specifically, my y-intercept's the easiest. I plug 0 in for x. I get negative 1/2, which is right here. which means I know, without plugging my calculator, it's going to skim there and come down and skim here. Now, if I were to find my x-intercepts, I think you'd find that one of them is over here, which means if there's an x-intercept there, then it looks like this. So the asymptotes present a technique we can use to help us come up with a graph of a rational function. Or you can plug in your calculator. Now I got YouTube videos out there on the last two topics, so we're going to stop there. Then I'll answer any questions you have.